All right, folks, let's go ahead and get started. Welcome to today's Endevor Community webcast. Before Vaughn and Vaslav take over and take us through their presentation, just a couple of things I need to go over first. First, a few questions during the session, and we always hope that you do, either questions or feedback. Please use the questions box along the right side of your screen under the GoToWebinar control panel to ask them, and we'll get through as many of those as we can during our time together today. If for some reason we can't get through all the questions, if there's too many, or if a question or two requires some further research that our presenters can't respond to today, I'll make sure they have everything they need to follow up with you after. We are recording today's session, and that's why you're all muted. The recording will be available probably sometime later today out in the Endevor community, along with the presentation. So if you have colleagues you want to share it with, please, you can please point them there. And the last thing from me is that we are always trying to ensure these sessions are valuable. So with that in mind, I pulled together a quick survey that will pop up at the end of the webcast. If you could stick around for a couple of minutes and give us some feedback, I know Vaughn would appreciate it, and so would I. That's it for me, so take it away, guys.
Thanks, Len. Welcome, everybody. So today's session is on setting up self-service parallel development with a new feature we recently GA'd. In 18.1 called Endevor Dynamic Environments. So we'll be talking quite a bit about this. So if you haven't heard of it, don't worry. Before we dive in, I'd like to go ahead and introduce myself, just in case you know I'm not. If you're not familiar with me, my name is Vaughn Marshall. I'm the product manager here at Broadcom for Endevor, as well as the Endevor modern interfaces like Bridge for Git and Team Build and so on. And I'm actually also joined on the call by our product owner, Vaslav Brunhofer, and he'll be covering one of our slides as well as available to answer any technical questions I can't answer. So with that all said, let's go ahead and dive in. So one of the things I wanted to talk about is, you know, one of the reasons that we've attacked this particular feature. Parallel development is really a key practice for practicing agile development methodology. And the reason is that you want to create essentially isolation for all of your changes. When you have limited you know, ability to separate changes from other changes, what happens is that changes start to become commingled. It makes testing a lot more complicated. You can create dependencies. So for instance, if you wanted to promote something, but your code has been mingled in with other changes and those other changes aren't ready, or maybe there was a bug found, then those dependencies become problematic. So the idea is to keep everything in isolation until the last minute. Now, of course, you know, changes that other developers are making are going to be moving in through the trunk continuously. And so you want to integrate those changes early and often, but you want to pull them into your parallel stream so that essentially your parallel stream is ready to go at any time into the trunk, and it doesn't contain anything that hasn't gone already ahead of it. And that practice essentially is one of the key things that gives you that agility that you're looking for to be able to go faster. So this is something that is very important to have when you start talking about agile development. And it's something that, you know, a lot of people have looked for in mainframe SCMs, you know, and talked about how can we do that. And we've taken a few cracks at that, and I'm going to talk about that as we go in. But that's really the why behind this. Now, in Endevor, we have a whole bunch of different ways to do parallel or concurrent development, and some work, you know, for different use cases better than others, and vice versa. So, for instance, if you're talking about a developer who wants to kind of use a modern interface, modern workflows like Git, obviously Git provides a lot of capabilities for branching, and you can even consider your local workspaces in Eclipse or Zowe to be branches in their own right, really isolated branches. And of course, if you've got something like Git behind that, you can branch in your workspace and switch contexts back and forth. But the key thing is, you know, what about those developers that are working natively in 3270 on the green screen? Or if you want to back up some of your off-host workspaces like Zowe or Eclipse by a green screen branch, what then? What should you do? And we've talked about different ways of doing this, and as I mentioned, we've had a crack at that. So here at Broadcom, our developers kind of came up with a way of doing this called sandboxes, and that's been around for a while. Sandboxes is essentially taking the subsystem field and using it kind of like a branch. So you create a subsystem that functions as a branch, and it works fairly well, but it has some limitations. First of all, your sandbox needs to be, well, it works best if your application can be contained entirely in a subsystem, and that's not always the case. And so because of that, it's not something that everybody could use. So it worked well at Broadcom. And we certainly have shared how you can use sandboxes and talked about the configuration and shared some processors in our documentation, but it's not widely adopted. So that was one of the main drivers behind this new way of doing parallel development, is instead of looking at it the sandbox level, let's look at it at the environment level. And I'm going to talk about kind of, some of the particulars about that in a second. The other aspect to parallel development in Endevor is merging. So, it's all well and good to create a branch or an isolated environment or a work area, if you will, but eventually you need to pull in changes from other people. Now, we actually have pretty good coverage here as well, some stuff new and some stuff, that's been around for quite some time. So the first one I'll call attention to is Parallel Development Manager, or PDM. That function lets you actually do merges in a 3270 environment. So we've had that for a while, and if you're using dynamic environments or sandboxes and you want to be able to do that kind of merging with a merge tool that's native to 3270, PDM's your answer. We also have the ability in Git to do merges, and we've done a whole bunch of improvements in our Eclipse merge. And of course, VS Code has merge in it natively. And the other one I will call out here is if you're using Zowe, the new Zowe workspace feature, which works perfectly well with sandboxes and dynamic environments, actually has a merge in it as well, a very Git-like merge, which lets you do auto merges and can even pull up merge editors with standard annotation. So if you're using tools like VS Code, you'll be able to do merges in that workspace in a very familiar way. So we think we've got a really good coverage now for the ability to do parallel development in Endevor. Dynamic environments is really the key piece that kind of brings that all together. So let me talk a little bit about why we went with dynamic environments as our branching solution. So ultimately, what we did is we kind of looked at how people do parallel development, today in Endevor without dynamic environments, and tried to kind of think, can we expand on that? So today, basically, most people that are doing parallel development in Endevor, they have, one or two or three or four or even more parallel development environments, essentially, and they will converge up the map. So there'll be a merge point up the map. So you'll have something like you see on the right here, Dev 1, Dev 2, Dev 3, merging up to test, staging, and prod. So, basically that's fine, except that with that new agile practices that I was talking about at the outset, basically the best practice is now to do branches on, every single change. And you can imagine that having Dev 1, Dev 2, Dev 3 is fine if you're doing kind of like parallel releases. But if you're doing isolation on every single change to try and implement Agile, then having a Dev 1, Dev 2, Dev 3 is simply not enough, right? So what you need to be able to do is be able to have as many of those parallel containers, if you will, as you want. So our approach was to take inspiration from that and continue to use environments in the sense that that's going to be the parallel path. That's where you're going to be working isolated, but really create the ability to have as many of those as you want. And of course, that addresses some of the problems that people have with sandboxes. For instance, if you've got an application that spans multiple systems and subsystems, you don't have to make any changes or create parallel sandboxes or anything like that. You don't have to worry about changing processors. So it becomes, those barriers to adoption for sandboxes are removed, and it really kind of elevates that whole parallel branch to the way people are used to working. Now, the nice thing here is because this is using an environment, and an environment is something that everybody's familiar with, it means that you can use any interface. If you want to use 3270 and have a parallel working area in an environment, you absolutely can. So, some of you may be wondering, hey, why didn't you guys do this before? And in fact, whilst this may have been considered, there were kind of a couple of things that really were barriers, and which we've, taken the last little while to work on to overcome. So the first one I'll talk about is the space. So if I take and have like a dev 1, dev 2, dev 3, but then I scale that horizontally out to as many parallel changes I want, one can imagine that the overhead of having all those environments and the space they use would be quite significant. And of course, that's true. If we were allocating the backing files for every single environment, and we had 200 environments, you would quickly go through your DASD. So the first feature that we considered critical to enabling this approach is something called deferred file creation. So essentially, you can now define your environment such that the files that back the environment are really only allocated when they're used. So let's say I'm only making a change to a small piece of my application. Yes, my whole application can potentially span lots and lots of systems and subsystems, but if I'm only making a small change to a small piece, it's only going to allocate the backing files that are needed for that. And it does it at the last minute. So basically what we're trying to do is avoid the space and ensure that minimum space is being taken up while you have the potential to use all of the features of a full environment. The other thing that we wanted to do was make sure that the creation of this new parallel environment would essentially not require a whole ton of administration and scripting and SCL and so on. So we've created new SCL that essentially lets you do this on the fly with essentially defining like an other environment. So you can easily spin this up with minimal administration and SCL. So let's talk a little bit about deferred file creation. So again, deferred file creation allows administrators to set up data sets that are only allocated on first use. So typically with the dynamic environment, you're going to want to use this. And by the way, if there are any customers on this call that are using sandboxes currently, this works equally well with sandboxes. So it's another way to kind of reduce your disk space. Even with a sandbox. But essentially, you can set these up so that the base delta, source and output libraries, processor output libraries, they can all be initialized only on first use. Right now, we support PDSs, PDSEs, sequential files, elibs, USS files, and we even actually support the post-create initialization of a file. So sometimes those files need to have something in them, as a kind of a baseline. So if you have that, you can have a post-create initialization as well. And again, this is all tied to being able to make sure your sandboxes and dynamic environments are not using unnecessary disk space. One thing to note, type definition files, base, delta, source output all have to be defined with symbols in their name. And explicit files and type definitions must exist. And then lastly, any processor inputs should use alloc equals cond. If you have input files that are using alloc equals lmap or pmap, those are going to be skipped. And so that's a very important consideration in terms of your processors. Okay, so one of the things you're going to want to do if you want to set this up is, essentially look over the doc. But here in a nutshell is kind of the steps that you need to be aware of when you're enabling this. So deferred file creation requires a number of PTFs. And depending on the support for added things like elibs or USS path names, or if you want post-create initialization, there's additional PTFs that need to be applied. And by the way, I'm going to take this deck and post it with the recording. So if anybody wants to use this deck kind of as a reference, by all means, please do download it. And it's enabled, deferred file creation is enabled through the C1 defaults table. You essentially need to specify the deferred file creation member of the parmlib dataset using DCF MBR equals. And we're going to be looking at some of the format at a high level in the parmlib and of the deferred file creation member in the parmlib with Václav in a few moments. But ultimately, that's all that's needed. Now, to enable dynamic environments, there's a couple PTFs that you need to be aware of. And the other thing that you should know is that the MCF for dynamic environments need to be defined at creation time. And we'll look at a processor that actually does this shortly, but the MCF is the one thing that can't be deferred. So the MCF must be defined at creation time. Everything else can be set up with DFC. There's a global control file for dynamic environments that tracks a number of different things, including the environment and I believe some of the ACM records. And that is a one-time allocation that is done as part of the enablement. And you then take the DSN for the GFF and add it to the C1 defaults in the type equals main parameter. And there's some JCL on the right that is shows you how to allocate the GCF. Okay, so that's kind of the high level on how you enable this. And now Václav's going to take us through some of the DCF member examples and just talk about, what it does it look like when you're setting up deferred file creation in terms of defining which files are allocated dynamically.
Okay. Okay. Hello, everybody. So let me just walk you through this slide. So I didn't want to go too much of a detail, so I just want to kind of high level to explain how the setup and how the configuration for DFC works for deferred file creation. First, I want to say that we have quite detailed documentation on it. So if you're interested, I'm not sure if this link will work, but yeah, definitely in our documentation in the section how to enable deferred file creation, you can see a lot of examples and a lot of different scenarios how you can use it with different types of data sets and USS folders. So just 3 examples to give you an idea how this works. So for instance, when you're running a processor and typically before you had this feature, an allocation of a data set would fail. So now if you have this feature enabled, so when an allocation fails, Endevor looks into this DFC member before there's any error with the processor. As Vaughn had it in one of the slides, this DFC member is referenced in C1 default. And the name of the member, and it's located in the parmlib. So this member consists of entries for either DSN for datasets or path for USS folder. And Endevor, when the allocation fails, go from the top to the bottom through this file and is looking for a match. So we can imagine these entries as rules. So there's a substitution for Endevor symbols, and Endevor looks for a match. So when the match is found, the data set is allocated based on the allocation parameters specified in this file. So if you take a look at the first example, so I wanted to demonstrate like two main ways how you can allocate a data set. So first is a like, so that's the simplest way. That's something we recommend unless different allocation parameters are necessary. So typically when you have an Endevor map, so for any, let's say, stage lower in the map, there's a missing data set, you can say allocated like my production data set for the same, let's say for the same type, for example. So just an easy way how you can allocate any data set lower in the map, like a data set higher in the map. So the second way is to be specific. So in case you can't allocate like, or you don't want to, you want to change the allocation parameters, you can be specific, you can be explicit. So as you can see in the below the like statement, you can specify everything, or you can combine the two. So you can use a like and then any of the if any of the parameters is specified below the like, the parameter from the like will get overridden. So for instance, the last statement in the first example is like width overriding the block size. The second example, I wanted to show you how the good naming convention can simplify the DFC member. So in this example, my first three statements are allocations for my base libraries for three different types: copybooks, COBOL, PLI. I don't have my datasets called after the type, so that's why I needed to be specific in the first three statements. But in my fourth statement, as you can see, I can just simply say for every base dataset ending with a specific type for that allocation, just allocate it like my production dataset. So it can get very simple with a good naming convention. Third example, I wanted to mention the sequence. So I said the Endevor goes from top to the bottom. So in case you want to be specific, for instance, you want to have something which is common for most of your data sets, and for, let's say, one type, you want to specify different allocation parameters. So for instance, for variable block data set, I want to set different parameters, always put it above the generic entry, so it doesn't get included, so it never gets to the second rule, let's say, for that type. So I guess that's pretty much it. There's you can definitely do much more with that. I didn't want to go to too much of detail. So again, in our documentation, we have a very good guide to how to work with DFC member. Okay,
Awesome.
Vaughn, so that would be all.
Thank you, Vaslav. And I'll also throw out to the community on this call, if anybody's interested in a deep dive on this, we can either do a follow-up community presentation specifically on DFC and how you set it up, and maybe go through some more use cases, or if you have just questions or would like a one-on-one session, we're always happy to talk to our customers and jump on a call and can brainstorm with you guys about how you might use this if you have questions. So I'll just throw that out there as well. Thanks, Vaslav, for that. Okay, so moving on. So you have DFC set up. You've got this ability now to potentially use a very simple new SCL to easily fire up a parallel dynamic environment. And of course, if you think about, again, parallel development and how it works in other systems where developers can create branches anytime they want and essentially contain their ideas, the same applies here. If you want your developers to really be agile, to take advantage of this new feature, then the developers are going to be best served if they can create these on their own. And the administrator maybe is there to assist if needed. Maybe there's an approval process, but even that, I wouldn't necessarily recommend. But nonetheless, a way for developers to be able to serve themselves, create new environments on demand is kind of key to keeping them agile. So how do we do that? There's lots of different ways. I'm going to show a couple actually in the demo. But if you're familiar with our sandbox feature, you'll know that the way we do it here at Broadcom is we actually leverage types. So we have, for instance, a type called sandbox. And if you want a new sandbox, you essentially create an element of that type and then generate it. And the processor becomes the mechanism to essentially spin up the sandbox. The exact same thing can be done here. So you can create a type, call it whatever you want, denv, dynenv, and then have the generate processor run the new SCL to spin up the environment. And you can have a delete processor clean up the environment when they're done. Though that said, you just be aware that the elements need to be promoted out. And actually that's a good thing, because that means you're not going to accidentally lose work by deleting an environment. Essentially, the delete processor will fail if the environment is not empty. So you can essentially make sure the developers have done all their promotions before you start cleaning up. And I'm going to talk a little bit about, a larger scale cleanup for kind of orphaned branches in a bit, but ultimately that mechanism has worked really well. And the advantage here is, again, it does not matter what interface you're using to work. If I'm in Git and I want to create an element of type Dyn environment, I can do that. If I'm on 3270, I can do that. If I'm working with Eclipse, I can do that. So this ability to do that natively in the tool is key, and it allows developers to work any way they wish. And of course, we've mentioned already the MCFs need to be created before as part of that processor. Everything else can be done in DFC. And then the other thing I'll point out too is if you want to do anything else, let's say you want to orchestrate additional, capabilities on top of spinning up your branch, so to speak, your dynamic environmental branch, you can actually absolutely do things within Zowe. So for instance, you could use Zowe Endevor submit SCL to spin up the environments, or you could even use Zowe to create those elements of type Dyn environment and then generate them. And I'll actually show that as part of our demo. But the nice thing about that is that let's say you want to not only spin up an environment, but also allocate a, maybe a test area or a test region, or you want to, run spin up a DB that goes with the test region, and anything like that you might want to do, you can extend out with that orchestrator. You can also do it in processors. It just depends where that stuff runs. So, but in any case, this is a key concept. You need to let the developers be able to request their environments and have it, be ready for them quickly, so that they're not, they're not hitting barriers as they're adopting these agile practices of isolating their changes. So let's look a little bit at the SCL. So as I mentioned, there's kind of some new SCL here that we created as part of the dynamic environments feature. And this SCL essentially makes the spin up a lot easier. So the first one, you can basically create an environment from an existing static environment. So if you've got dev1, dev2, dev3, you can pick one of the environments. And in fact, this SCL here is actually looking at, it will, if you were to run this, it will, let's say in a processor, it'll run from whatever environment you invoke that generate processor. And so the idea here is you're just basically cloning an environment using define like. Now, the environment itself can have all the systems in them, none of the systems. You can then selectively clone what you want into that environment. If you do them all, they're all available. And remember, they're not going to take space up because because of deferred file creation. But you can also limit it. So if you have like a good naming convention and you only want certain sets of systems for one set of developers, then you can limit which systems, subsystems, and types are going to effectively be in that dynamic environment. And of course, delete environment will clean up. And as I mentioned, when you're cleaning up environments, one thing to be aware of is that you want to make sure the elements are promoted out. It's not going to work, and also that the job's going to need to clean up the MCF. So just a few things to be aware of there. So this is a sample processor or a generate processor that will create a dynamic environment. This is actually right out of what we're using in our demo. You can see that the very first step here is simply setting up a vSAM for your MCF. So again, that has to be created first before you can create the dynamic environment. Everything else can be dynamically allocated later. And then here we're using the admin batch utility again to do the define like, and this is the same SCL you saw, and then the SCL to clone the systems in there. So, that batch utility runs, you essentially create like an environment like and in parallel to where you are when you run this, and then sets up the systems, without all of the backing files except the MCF, so that, you've got a space to work, and the space only gets chewed up if you actually use those things, okay? So pretty simple. And then, of course, the other thing that a lot of people ask when we're talking about dynamic environments is our security. And security is actually a key piece of this. So there's kind of two aspects of it. The first one is, the actual security, like who's allowed to do a dynamic environment, right? Is that an admin function? Can developers do that? And so on. And of course, one approach, if you're using that processor approach, is that the alt ID can be the one doing this on behalf of the developer. But if you want the developer to run the SCL directly and so on, or if you're defining this as an admin function, essentially you would use the primary options entry in the security table. We use the menu keyword, which for environment resolves to envrment, and essentially it creates, along with the environment name, a pseudo data set name. So for instance, C1, the name of the environment, P menu, and then the specification for environment, which is envrment, as I said. It creates that pseudo data set name for a read check. If the user can actually read that according to ESI, then they can define, update, and delete those dynamic environments, okay? Now, as I mentioned, a good thing to consider here is a prefix or naming convention and restricting that so that you can make sure that you can deal with security without having to make individual entries for every name or request them after things are spun up. It should basically flow down automatically. So you want to make sure that you're using some sort of prefix or naming convention, like the example here, so that security doesn't become a maintenance nightmare. Likewise, you want to have the dynamic environment name in all the data sets and definitions that pertain to it. And again, this is so that you can define rules for who can access those data sets and actions on them. And that makes it a lot easier to deal with security. So hopefully that's clear. We're actually going to be publishing an article on this. And by the way, there's going to be a whole blog on this to kind of go with this webinar, which I will be posting in communities and sharing out on LinkedIn. So you'll have lots of resources to try and follow through and adopt this. But in a nutshell, naming convention is very much key for your security when you're setting up dynamic environments. You don't want anybody to just be able to name anything, an environment anything. Okay, the last thing I'll talk about is cleanup. So again, if you're used to using, say, a tool like Git, you'll know that you can branch to your heart's content, and generally, you'll do pull requests, you'll merge, those branches will then effectively be merged into the trunk, and typically you can clean up old branches and do a bit of housekeeping so that you don't have all of these things to wade through and to ensure that your work with the tool is clean. Same concept applies here. You may want to clean up any environments that are no longer in use. Obviously, you don't want to lose code, but there may be times where a branch was used for a specific idea that nobody is interested in anymore, or it's abandoned. You can use the CSV utility, first of all, to list your dynamic environments. So there is a flag now in the CSV utility that will tell you if an environment is dynamic or static. And then second of all, you can use the list elements function, whether via CSV or Zowe, and if essentially you can find any dynamic environments where there's elements that have not been updated, that have been updated after a given time. And anytime you find an empty list, essentially what that means is that nobody has touched any elements in that dynamic environment for XXXX time span, whether that's 6 months, a year, etc. And if that's the case, then this is a potential candidate for cleanup. Or if the branch is just empty, that would be another candidate for cleanup. Empty and hasn't been used, in XXX time. So ultimately, you have a mechanism for finding these things. And in fact, this is something we practice here at Broadcom with sandboxes. Again, we don't use dynamic environments, but the same principles apply. Essentially, when I make a sandbox and I don't do anything for it, I get an email warning me that the sandbox should be cleaned up. And of course, you can tie that to an automated process if you want to do the cleanup. But yeah, it's always a good practice to warn the users before you delete anything and to allow plenty of time. Again, we have minimal space use, so it's not a huge concern, but a periodic cleanup of your dynamic environments is a good practice. Okay, so with that, I'm going to go and do a quick demonstration, and then we'll just summarize where we are and open the floor to any questions. So hopefully you guys are filling that question and answer box with questions, but if not, no worries. But if you do have any questions, we're happy to answer them on this call. All right, so let's go over to my, my VM, and I'm going to start over here in Endevor. So you can see over here, I'm in Endevor Classic, and as a matter of fact, you can see this is my environment list, right? So I have some pretty basic environments, a dev, QA, prod. There's our sample app, but in any case, that's my map. And if I want to see how I can, let's say, make a parallel dev environment for my work, let's go and look and see what we have set up in dev. So I'm going to go in here. And the first thing I'm going to show you is the processor group that I've created for the type DENV. So we'll go in here and I'll look at my processor group, and we can see in the dev environment in system ALC test, I have a type called DENV, and it has a processor group associated with it called dynenv. So if we click that guy and come in here, you can see I've got a generate processor called gdynenv, and in fact, it's the processor we were looking at on the deck. I also have a delete dynenv processor, and these things are essentially the automation that is going to do the spin up and spin down of my parallel environment as I'm working on things. So if we want to exit out of here, we can go into quick edit, and we can actually look at that. So this is where the processors live in the system. I'm going to go ahead and enter in here, and we can scroll down. So there's the delete dynamic environment processor. Let's have a look at the generate one. That's the one we'll be spinning up. We'll browse that, and you can see it's pretty much what we were showing there, with one minor change. In our version of the processor, we're pre-allocating the output data sets for the batch admin utility. Actually, you don't need to do that, but anyways, that this flavor of the processor's there. There we define the MCF, right? And then we run with the batch admin utility the SCL. We're using the define environment like syntax. And then in my case, I'm only cloning one of the systems. I'm working in ALC test, so I'm only cloning. Actually, let me go back up here. I'm only cloning that one system as part of this. Okay, so that's pretty much it. That's my my processors. So what does it look like if I go ahead and spin up a dynamic environment and make some changes? So first thing I want to do before I actually go into this, I've got my screen split over here. So this is my backing data sets. I'm going to create a dynamic environment named after me, VM01. If I hit enter on here, you can see no data set names are found. So basically, none of this stuff has been allocated. And the reason I'm showing you this is we're going to watch and see these guys get picked up via deferred file creation as I work and be allocated just in time. Okay, and this of course applies to any of the backing data sets. But anyways, let's go ahead and do that. So I'm going to go back into quick edit. And using quick edit, I'm going to go into my dev environment and I'm going to create an element, and we'll call it VM01, and it's going to be type DENV. We'll put some CCID and comment there. So this is in dev ALC test. My subsystem in ALC test is GA, and I'm going to go up here and create this guy. So we'll go ahead and create this element. Okay, so I'm creating an element of type DENV, and I can put whatever I want in there. So let's say new new dynamic environment VM01. Okay, something like that. And then I exit out, and of course my generate is going to automatically be invoked. And essentially, this is running the generate processor which is now in process of spinning up that dynamic environment for me. And of course, while that's running, let's go back over here. I was thinking, hold on here. Give it a few minutes. But I'll show you that still the files have not been allocated. So even though I've spun up this environment, those files are not there. Sometimes this system's a little slow there. Okay, so let's see what's going on here. There we go. Whoops. Oh yes, I hit F9. There we go. So there we can see that the dynamic environment processor has run. Okay, so that's completed. And let's go back in here. I still hitting enter. I still have no data set names or backing data sets for this. I do have the MCF, but nothing else. Okay. Now let's exit out and just to go in, I'm going to go actually into Classic again. And we should see, yes, there's a new dynamic environment right here. Okay, so it's at this point, it's just a regular environment. It's been allocated. I can go ahead and work with it. So I'm going to go ahead and do that. We'll go into Quick Edit. I'll clear this type, and we'll go into my new environment. And let's have a look. So I'm doing my query. You can see it's going up the map. So it's copied the same map as I had from dev, except it's coming from my new isolated environment, VM01. And I can pick any one of these files. So let's go ahead and we'll grab this assembler file. I'll edit it. Of course, it's getting pulled back by Quick Edit. Okay. And again, if I go back over here, still no data set names. That's going to happen when I actually save this. Okay. So let's just make a small change. I'll repeat the comment line, nothing fancy, and I'll back out of this, which again is going to invoke the generate, this time the assembler generator. It completed, and now let's go back to my list of backing files, and there they are. You can see it's created them. So it does that at the last minute, and it does that as needed. You know, if there was no processor here associated with that, it would just have the code containers. But because I did a generate, you can see the object library and so on were created. So it allocates whatever it needs on the fly. And that's pretty much it. So now I've got this guy. You can see that it's in here, right? The environment has been created. And that I have my copy of this sitting in stage 1. Now, I can continue coding and promote and do all the things I would normally do. Let's say I'm doing a cleanup and I've abandoned this idea. I can come in, and as long as I delete this, okay, and exit out, at this point, I can come into the environment and very much like I was doing with that same element. So we have element VM01, type dnv. Right, and this is again in dev. So we'll come in here. There's the environment, and if I delete this guy, so let's go ahead and do that. Okay, and now I'm going to back out of here, and let's have a look in that first panel on Endevor Classic. We should see that environment is gone. Okay, so it's that simple. You can spin these up. You can have your developers work there. It takes minimal space, and they're able to, work in isolation on each change as needed. And that can even be a change that's, shared amongst more than one developer, right? They can be working on a project in that container. So key practice supporting agile development and velocity, making sure that your developers have maximum velocity, fully available in Endevor, along with other ways you can do parallel development. Now, the last thing I was going to show you over here is, what if I want to do this kind of in a more modern way, or I want to tack on off-host automation? You can do the same types of things in Zowe with tools like Jenkins or any orchestrator. This could even be a service catalog if you want. And just for fun, I put a little approval stage in here to show how you could say, if you do want to be kind of in the mix as the administrator, make sure that you have a little bit tighter control on the on the dynamic environments that are being spun up and down. In this one, you can create an approval. this submitter means that this has to be somebody in this group or ID in Jenkins that would be the approver. So a developer can spin up a request and then an approver can come in and approve it. And then of course, this just creates that same element and does a generate. You could do the same thing with packages if you want a more Endevor native way of doing this, right? So you could have the move processor do what the generate processor does and have the package as an approval mechanism. Those are all valid. Anyways, let's go ahead and run this guy. I'm going to go ahead and hit run, and we'll give this another name. I don't know. Let's say what's a good one? Let's say I don't know, community environment 01, something like that. Okay, I'll hit run, and you can see what happens in Jenkins when you have an approval process here. It's going to pause in a sec. Actually, let's go in there, and it's going to come back in half a moment. Right, so actually what it did first is it checked out my Jenkins file from my repository. Then it came to the approval. I happen to be an approver, so I'm allowed to come in here and say that I can approve. So I'm going to say, yep, go for it. And now it's going to go and do basically what I did in the green screen, but via Jenkins. So when this is done, we'll go back in and we should see that environment sitting there and available again for use. So this is just another flavor of how you can self-service things. And then, of course, the advantage being that you can take advantage of whatever you want to put in there in Jenkins if you wanted to have add-on processes like initializing a Kix region or something like that with the associated with the new environment or whatever you can think of. So that's going to take a few moments to run. Maybe while that's running, well, let's just give it a few minutes here. So again, if you've got any questions, hopefully you're adding that into the Q&A box right now. Let me go, well, let's just see, we'll be patient. It took a few minutes last time, so I imagine it's going to be the same here.
Vaughn, we do have a couple of questions. Do you want me to go ahead and ask those now?
Why not? Why don't we start with that?
All right, so let's go with the first one. When deleting a dynamic environment, should an MCF reorg be included in that process?
An MCF, so the MCF tied to the dynamic environment is not going to be needed anymore. So I'm not sure I follow. I think you basically just want to get rid of it. Václav, do you have any thoughts on that? Am I misunderstanding something?
No, what you said was correct. Yeah, you basically want to delete the whole MCF since you have to use for that environment.
Yeah, it's kind of like a branch in Git. It's pretty much throwaway. I mean, you could keep it around, but for the most part, you really just want to get rid of it. It's unless you've got a reason to keep it just in case. But anyways, yeah. Okay, that finished. So let's just go in here and do, just for pedanticness, we'll go in and see that new environment. There we go. So we have our community, a community edition environment. Okay. So let's go back, actually, just kind of wrapping up. Again, we showed kind of Agile and how developers can use isolation with dynamic environments. We showed how, it's a much lighter lift now administratively and avoid disk space. And self-service is a key practice. And of course, naming convention for security is one of the other key things you want to keep in mind. So apart from that, we've had one question. Len, you had mentioned a couple more.
Yeah, there's a few more in here. I can go ahead and read those. Next one, how many dynamic environments can you create? Is there a limit?
That's a great question. I don't think there is. Václav, do we have any limits that you're aware of? I don't think we do have any. You can have as many as you want.
No, the only limit is the number of records in the GCF file or disk space, basically.
Yeah. So if your GCF file runs out of space, then you're stuck. Again, that would probably be quite some time.
All right. The next one, when using like, does it respect established SMS ACS routines?
That is another question I'm going to have to defer to Václav. I think it would, yeah. But Václav.
I'm not sure, to be honest. So you're talking about like when creating a dynamic environment?
Yes.
Yeah. By the way, if there's any questions we can't answer, what we'll do is we will take them offline to our architects, and we'll get them to weigh in and follow up with. So maybe that one I'll take offline, just to double check and just to ensure we know what the scope of it. Or we're talking about you know, the when you're using define like, not the not something in DFC. We're talking about that SCL. So we'll check that out. Any other questions, Len?
Yeah, there's a few more in here. Can you explain the merge process?
Okay. So the merge process. Wow. I don't have that readily set up right now to demo, but I can talk through what it looks like. Ultimately, you know, the way things work, and if you're using one of our FDPs, field develop programs, which are available in the community for retro, this works nicely with quick edit. Essentially, what you do is you find another. So let's say you're working with code that. Well, actually, this would probably be easier to explain with a picture. So I'm just gonna go to the picture of the map over here, and I'll talk about the merge process a little. Okay, so here's the map, right? So ultimately, picture that you have, you know, a dev 1, dev 2, dev 3, dev n, and so on. These are all isolated changes, and people are making changes in each of their containers in parallel. Now, let's say somebody's change is in dev 1 and they're ready to promote. They're going to go up to test and ultimately to staging and production. And essentially, when they do so, you know, Endevor is going to do like it always does. If there's a sync error, it's going to force you to merge and so on. But ultimately, that that promotion, you know, if there's nobody, if you're the first one to go out of all the parallel changes, then you're gonna be the winner effectively. You won't have to do a merge. Now, at the same time, you know, you want to follow the practice of merging early and often. So you're going to want to take what's going into test on a regular basis and bring it in to, let's say you're working in dev n, you're going to want to bring it into your isolated change. And that's so that when you're ready to go, your changes, you know, contain the latest changes, and you're not going to get the sync errors and so on. And the best practice is to do that early and often. In other words, don't wait, like do it periodically as changes are moving up the map, not at the end right before you're ready to go. Otherwise, you may have a whole lot of merge things to do. And it also means that you're continually testing. And the tool essentially just lets you, like the merge tool, PDM, essentially lets you take, you know, point at one location and point at another. And then basically you can create a merged file. They have something called a work in progress file. And then if you're using retro, you can add it right back into quick edit and replace what you were working on. So that's ultimately how all the merge tool works. And you would do the same thing, you know, if you were using Zowe. So let's say I'm using the Zowe workspace and I want to use the auto merge. You know, effectively you would have this dynamic environment, and that dynamic environment might be paired to your workspace on your machine. But at the same time, other people are moving their changes up. If you run the Zowe sync command, you're going to get you know, those changes and bring them into your environment, and you can then merge and so on. So that's essentially it. You know, the merge, it depends again specifically on the tool. Some of them will bring up graphic merge editors. Sometimes you can do that through PDM. But ultimately, that's the idea. You're going to be pulling in the changes from the trunk as they're moving forward into your isolated branch, and then when you go forward, because you've been doing that continuously, you'll be confident you can, you know, promote even with sync. So good question.
All right. Yeah, unless you have anything else to cover, we do have a few more questions in here.
No, go for it. By the way, I can also add that if that's another topic people would like to see, like a deep dive on merging to kind of go with this, happy to do that. I'm always happy to, you know, share information and have discussions on these webinars, either one-on-one or as the community. So feel free to pop a comment or a suggestion that we do some of those follow-on things into the community, and we'll set up a webinar.
Great point, Vaughn. All right, next question. Can you create multiple multi-environment life cycles dynamically? For example, a dev that feeds into a QA.
Sorry, can you repeat that? I didn't, it
Yeah,
broke up a
sure.
little.
Yeah, it's okay. Can you create multi-environment life cycles dynamically? For example, a dev that feeds into a QA.
So you mean, so you could maybe have let's say the merge point was stage, and you had dev goes into test, then it merges at stage, and you would want to create like, a dev end and a test end. Is that, I think that's what you're asking. And I don't see why not. I mean, it's just a matter of making your SCL do that. Again, I'll ask Václav if he has any thoughts on that, but I think you can, you just, as long as your SCL is set up the way to clone things like they are, you can absolutely do that.
Yeah, I understood in a way whether, for instance, you could create the whole map, a dynamic, from the dynamic environments. Yeah, that absolutely you can do that. Or just the sequence needs to be that always the next one needs to be created first.
Yeah.
So there's always a next environment existing. Yeah, absolutely you can do it.
Yep. Another great question.
Yeah. Here's one more. I'm gonna try to get through this. How does the mapping of the dynam.env on existing static env work? How and where is it find the next stage or environment? I don't know if that makes sense to you guys.
Yeah, let's see. I think you're asking, let's go to the SCL here. Here, is this where? How does the, whoops. So this is where you define the next environment. So I don't know if maybe Václav, did you understand that question? Maybe I am not as much.
Yeah, I think I think it's exactly what you're showing. I want to point out that you don't have to have the next environment specified. For instance, if you're like defining like a parallel dynamic environment where the next environment is the same. So in that case, you don't even have to specify it. So the next environment can be a dynamic environment or a static environment, whatever you want.
Yep, exactly.
All right, guys, we are at the top of the hour. There are a couple more questions, but guys, I'll make sure that you get everything you need to follow up with this customer after the fact. We really appreciate your time today, and just a reminder that we do have that survey that's going to pop up when I close. That's a perfect place to put in future webcast topics and also give us some feedback. We really appreciate it.
Awesome, and I'll just say thanks, Václav, thanks, Len, and thanks to everybody that attended. And hopefully this is something that you guys find valuable, and we'll be standing by to help you if you guys want to try it out.
Great, thanks everybody. Have a great day.
All right, thanks, bye-bye.